types of images. One is a real image. Another is a virtual image. Okay. So what is a real image? Here, it's not a real image means it's really an image. It's not that. There is a meaning to that. But virtual image is that image that you see when you stand in front of mirror. Our images in mirrors are virtual. Okay. And every virtual image is erect. Okay. So what is a real image? What is a real image? Real image is an image formed by the actual intersection of reflected, and when we go for lenses, refracted light rays. Okay, so this is the definition of real image. What is a real image? Real image is that image that is formed by the actual intersection of reflected or refracted light rays. Then what is a virtual image? Virtual image is the image formed by without the actual intersection of reflected or refracted. Refracted means when we come to lenses, then this definition holds more. Refracted light rays. Okay, so this is the basic definition. So what is real image? Image formed by actual intersection of reflected light rays in case of mirrors. Virtual image is image formed by without the actual intersection of reflected or refracted light rays. So this is the basic definition. What does this definition mean, right? What does this definition mean? Let's see what it means. We are seeing the types of image. So I just put the screen up to real image and virtual image up to that. Okay, so you see, in case of concave mirror, whenever you draw ray diagrams, see that ray of light is always incident from left side to right side. Means what? Polished surface should face the left side. Okay, so that we will have in mind. Some reference books put the mirrors in however, whatever direction, but according to sign convention, we have to follow this. Okay, so that's the concave mirror, outside painted, inside polished. Okay, and this is that principal axis. This is the pole. Okay, so what is a real image? You see, when parallel beam of light rays fall on this concave mirror. Okay, then after reflection, these incident rays converge to a point on principal axis that is called a principal focus. So this point where all the reflected light rays intersect, that is called principal focus, and that is the location where image is formed. Now see, this image is formed by actual intersection of reflected light rays. Okay, so this image is a real image. That means, how do you identify? I'm saying, how do you identify a real image? Real image is that image which is formed by actual intersection of reflected light rays, or the virtual image. See, in case of a convex mirror, okay, so there's a principal axis, and this is a pole, and you know that parallel beam of light rays. After reflection, in case of convex mirror property is parallel beam of light rays, they start diverging from a point on principal axis. So parallel beam of light rays will diverge. And from where they will diverge? They will diverge from a point on principal axis that is called principal focus. Now it appears as if, it appears as if all these rays have, it appears, okay, that they all must have started from this intersecting point. Okay, that intersecting point is where image is formed. And this image is formed by without actual intersection of reflected light rays. Means it appeared that those all diverged light rays have started from there. That means that's an intersecting point. But really it has not done that. Such kind of an image is called a virtual image. Okay, so that's the basic definition. All right. Then one more point for real image. Actually, we have to remember this. A real image is the image formed by actual intersection of reflected or refracted light rays. Virtual image is the image formed by without the actual intersection of reflected or refracted light rays. Now you see here, this first ray diagram itself, if you see, here if I happen to put a screen, I can catch the image of the object on the screen. But this place where in case of what is it called? Convex mirror. In case of convex mirror, I can't put a screen inside, where is F for convex mirror? F is behind the mirror. Means what? If object is in front, image can't be behind. No, image will be inside the mirror. And inside, actually, though ray diagram shows that image is formed behind the mirror, but that's not possible. No, if object is in front, image is inside the mirror. But while drawing ray diagram, we are showing that F is behind. Okay, but convex mirror, behind nothing is there. Inside a principal focus will come. Okay, so in case of convex mirror, we can't put a screen at F. But in case of concave mirror, we can put a screen in front of mirror. Okay, that means I can stand in front of mirror. Say, for example, I'm standing in front of plane mirror. I can't hold a screen and catch my image. My image will be inside the mirror. I can't take an image of mine on a screen if I'm standing in front of a plane mirror. Similarly, so concave mirror, image can be caught on screen. Convex mirror, image can't be caught. Why? Because F is inside the mirror. Okay, not behind. So real images can be caught on screen. Virtual images cannot be caught on screen. How to remember? Just remember these two ray diagrams. If you can remember these two ray diagrams, you can remember that where the image was. Okay, last point. All real images are inverted. All real images are inverted. That means they'll form upside down only. Okay, the eating spoon, you try to see your face, your nose will be upside down. Okay, but if it is very closer, that's why. Okay, virtual images are always erect. Virtual images are always erect. When we see ourselves in the plane mirror, we are erect, we are not upside down. So actually real and virtual words, we will use much when we talk about spherical mirrors. Okay, so rules of image formation for spherical mirrors. In case of concave mirror, what is rule 1? Rule 1 is a ray of light incident parallel to principal axis after reflection passes through principal focus. So this is the first rule in case of concave mirror. The first rule in case of convex mirror is, say this is the pole of the mirror and we have F and we have C. This F and C, they are not behind the mirror. Actually, they are inside the mirror. So if a ray of light is incident parallel to principal axis, after reflection, it appears to have diverged from principal focus. Okay, so this also means that principal focus for concave mirror is in left side, and principal focus for convex mirror is in right side. Okay, something else to know from this diagram. Sometimes they ask us label angle of incidence and angle of reflection in this case. So for that, this was the incident ray and this is the reflected ray. Okay, so at point of incidence, we have to draw normal. At point of incidence, if you draw normal, then the normal means what? Okay, and at a point at this point, I want to draw a perpendicular. Means what? I have to take this small section as a straight line. Means what? This will behave like a tangent. And any normal to this tangent, okay, anything that is perpendicular to this tangent is guaranteed radius of the circle. Okay, so that's what I was saying. So at the point of incidence, if we happen to draw a normal, the normal will be radius. And radius is the line joining this spherical mirror and center of curvature. Okay, center of curvature is center of the hollow sphere of this mirror, of which this mirror is a part, right? So this normal, if you draw at the point of incidence, that guaranteed passes through center of curvature, because center of curvature is center of that sphere of which this mirror is a part. Okay, right. Now, which is angle of incidence and angle of reflection. Okay, angle of incidence is angle between incident ray and normal. This is I. Angle of reflection is angle between reflected ray and a normal. That is this. Okay, so this basic labeling sometimes they ask us. Okay, angle of incidence and angle of reflection you saw. Let us do the same for convex mirror. So at point of, this is incident ray, this is the reflected ray. At point of incidence means here, I have to draw normal. Normal means if I draw normal at this point of incidence, it is definitely going to pass through center of that sphere of which this mirror is a part. So normal will pass through C, center of curvature. So this is N, right? And C. What is angle of incidence? Angle of incidence is angle between incident ray and normal. Angle of reflection is angle between reflected ray and normal. Okay, so this is what they ask us most of the time. Okay, though this is rule 1. Rule 1 is if a ray of light is incident parallel to principal axis, after reflection, it passes through F or appears to have diverged from F. Okay, that was rule 1. Let's go to rule 2. I hope you can remember this first rule. For any ray diagram, we want any 2 rules, TWO, 2 rules. Okay, let's go for the second rule. Rule 2. You can scribble in your rough book to remember. Rule 2. Okay, we will do it for concave mirror as well as the convex mirror. Okay, so concave mirror is the mirror which is painted from outside and inside is the reflecting surface. Convex mirror is the part of hollow sphere whose interior is painted and exterior is the reflecting surface. Center of the mirror is the pole, and then we have principal focus, and then we have center of curvature. Center of the mirror is pole, then we have a principal focus, and we have center of curvature. What is rule 2? Rule 2 and rule 1 are vice versa of each other. Okay, first rule was a ray of light parallel to principal axis. After reflection passes through F. Rule 2 is if a ray of light is incident through principal focus on the mirror, then after reflection, it goes parallel to principal axis. Clear? That was for concave mirror. And for convex mirror, if a ray of light is incident in the direction of a principal focus, then after reflection, it goes parallel to principal axis. Okay, for this also, if we want, we can show angle of incidence and angle of reflection. Means what? At the point of incidence, you can draw normal, and that normal, anytime any normal to a plane mirror will definitely pass through center of curvature. Why? Why? Because I told you this is the tangent and you are drawing a perpendicular. Tangent and radius of the circle are only perpendicular to each other. So that's why any normal to the mirror at any point definitely passes through center of curvature. Center of curvature is the center of the hollow sphere of which this mirror is a part. So it's a normal. Okay, and then which are angle of incidence? Angle of incidence is angle between incident ray and normal, and angle of reflection is angle between reflected ray and normal. The arrow directions are telling you which is incident ray and which is reflected ray. Okay, right. And the same thing you can do here also. At the point of incidence, if you happen to draw normal, it will pass through C. This is the normal. Okay, and then what is angle of incidence? This is the angle of incidence. And this one is the angle of reflection. Okay, that is rule 2. Rule 1, rule 2 were simple. Ray parallel to principal axis, it will pass through F. Ray through F, it will go parallel to principal. So this is pole, principal focus, center of curvature. Shakti, are you the ray diagrams that we are about to do? Is guaranteed perpendicular to the section of the mirror, because line from center of curvature to the mirror is actually radius of that light is incident through C. Its meaning is it is incident perpendicular to the mirror. Okay, so this is that incident ray, and this incident ray is incident on the mirror perpendicular. Means if I have a plane mirror and this is normal, okay, and this is that incident ray, and this is that reflected ray. This angle is called angle of incidence. Okay, and this angle of incidence, if it is a 0, angle of incidence is 0. Its meaning is what? Its meaning is the incident ray is incident. Incident ray is incident through normal. Means there is no angle. There is no angle between incident ray and normal. Okay, so here also this incident ray is ray of light is incident through center of curvature. Ray of light is incident through center of curvature. Its meaning is it is incident perpendicular on the mirror. So this will be reflected back in the same path. So how we state the rule? The rule is if a ray, rule 3 is if a ray of light is incident through center of curvature, it is reflected. After reflection, it follows the same path back. Okay, so the same thing in case of convex mirror also. When a ray of light is incident on the mirror in the direction of center of curvature, then after reflection, it follows the same path back. So this is the rule 3. Keep this in mind. Whenever a ray of light is incident on the mirror through center of curvature, it is going to follow the same path back after reflection. Okay. And the last rule, fourth rule. Rule 4 is for concave mirror. For concave mirror, okay, this is the pole. This is principal focus C, and for rule 4 for convex mirror, 4 rules. This is principal focus, pole, principal focus, center of curvature, right? And then what is rule 4? Rule 4 is if a ray of light is incident on the mirror obliquely at the poles, after reflection, it is reflected obliquely with respect to principal axis. Okay, so if a ray of light is incident, if a ray of light is incident obliquely at a pole, it is reflected also obliquely. Okay, so that means what? Here this is angle of incidence and here this is angle of reflection. Same thing in this case, ray of light incident on the mirror obliquely. In case of say concave, the first ray diagram I'm going to do that only. So a ray of light, beam of light or parallel beam of light, if they are incident parallel to principal axis, after reflection all of them converge to a point on principal axis. That point is called principal focus. Okay, so this is the case where image is formed on principal focus, and because all the light rays have intersected at a point, the image is very small sized. Okay, similarly, you see the same case, concave mirror, parallel beam of light rays. In this case, in this the first case, okay, parallel beam of light rays were parallel to principal axis, so image formed on F. But if parallel beam of light rays are incident on the mirror, but they are not parallel to principal axis, then also image should form. So what happens is these all rays of light, they don't intersect on F. Instead, they all intersect at F. They all intersect at F. Okay. All right. So anyway, I don't know. You didn't ask this. I know you were asking in this case, the ray should diverge, but from where it will diverge? Diverging means it should be parallel to first case is highly magnified and next is just magnified. Last case, when object is between F and pole of the mirror, image forms inside the mirror. And this is the case of a virtual and erect. Virtual and erect image. And this is also highly magnified. Okay, that is first 5 cases. Image of object is the reverse or upside down, and the last case it is virtual, erect and highly magnified. Last case is called the case of dentist mirror. That means a dentist will have not these days, once upon a time, these days the technology has improved. Now nobody watches the tooth, the behind tooth or the wisdom tooth with a concave mirror. Now the cameras, those all have come, but once upon a time the long plastic something like a stick, and at the end a concave mirror, and that concave mirror was placed near the tooth to see the magnified image of the tooth. So that last case is the case of dentist mirror or jewelry mirror or shaving mirror. Sometimes they ask us draw ray diagram of shaving mirror or dentist mirror. Those are, we have to draw the last case. So these are the cases of image formation for concave mirror. Okay, and actually I'll not ask you whether you have understood this. It is actually how the image formation occurs. Like if I know this, then when I draw, we can verify, like cross check. We can cross check whether when I placed only one case of highly magnified. Yeah, Shakti, I am clear. I just yeah. Oh, nice that you have a book beside. Okay, exactly. You are right. Highly magnified is at F. Okay, because when object is at infinity, image was diminished. So its opposite should happen when object is at F. Correct. Yeah. Thanks for correcting. Okay. Yeah, I know that there is only one place where it is highly magnified. Some books write big, magnified, big. Okay, as if that one terminology is going to change that, but this is it. Yeah, thanks. Okay, so I'm just moving on the screen. We'll go for convex mirror. Okay, right. Okay, so in case of convex mirror, Convex mirror is used as a rear view mirror in vehicles. Okay, so sometimes they ask us why convex mirror is used as rear view mirror. Okay, so nice. When we use the rear view mirror, we'll know much answers by, when we use it, we'll know why it should be used, and concave mirror should not be used. These are first 5 cases of image formation. All images were real and inverted. Concave mirror shows upside down, but convex mirror won't do that. Okay, like we have a huge traffic and all the traffic is upside down, that won't alert us while driving. But if the image behind is erect, that will definitely alert us. That's why driving vehicles. Okay, so nature of image and size of image. Okay, so convex mirror. Convex mirror is otherwise known as a diverging mirror used for rear view. So there are 2 cases of image formation. Okay, why there are only 2 cases of image formation? That's very interesting. So you have a convex mirror. Okay, and you see where is for concave mirror, we were saying at infinity. So here also we'll have at infinity. Remaining all we had beyond C, at C, between C and F, at F, between F and P. So those all chances are not there. Why? Because F is inside the mirror, C is inside the mirror. Say we don't want to understand that F and C are inside the mirror, we take it as they are in the right side. Okay, but object is always placed to the left, and left side we don't have FC to have those all 6 cases. So either object is at infinity or it is not at infinity, it is somewhere on the principal axis. So we'll have only 2 cases. Okay, right. So O stands for position of object and I stands for position of image. So object at infinity. Object at infinity and object not at infinity. Not at infinity means I just write it as object is on principal axis. Object is on principal axis. You don't want to write principal axis, or you don't want to write object on principal axis, then you write the second one as not at infinity. They will mean the same. So object at infinity. Then image.
Between infinity and the pole.
Between infinity and P. That's also a point. Okay, we can have it between infinity and P. That means not at infinity, right? That's nice. Okay, so image, where is image formed? Image is always formed at or on principal focus. This at or on, if the parallel beam of light rays which are incident on the mirror, they are parallel to principal axis, then on F. At F, if the beam of light that is incident on the mirror is not parallel to principal axis. Okay, so like this, we can have two ray diagrams for at and on case. Okay, right. So object is not at infinity. So image forms between principal focus and the pole of the mirror. Okay, that means either image, if object is at infinity, image forms at or on F. If not, image forms between F and P. So that's why they ask us for convex mirror, what is the range of image formation? Range of image formation means you have to tell length. So range of image formation for convex mirror is always a focal length of the mirror. That means between F and P, image is going to form somewhere from F up to P. Okay, right. So nature of image is always, wherever the object is, nature is always virtual. Means image is formed by without the actual intersection of reflected light rays. And all virtual images are erect. That's why rear view mirror. Rear view mirror means the behind traffic will not look upside down. They will always be as they are. Okay. and the size of image is always small. Diminished for the first case, and numerical problems on reflection topic with that reflect. So these are ray diagrams, in fact. Ray diagrams for image formations. Not interested. Okay, right. Ray diagrams for image formations. We begin with concave mirror. Concave mirrors, those all will come. Okay, so this is an easy way of learning. Okay, right. So ray diagrams. Actually, you must have seen those. They must have written U negative, V positive, negative, depending upon which side the image has formed. Those all. We'll come across those. Okay. So, yeah, concave mirror, otherwise known as converging mirror. Actually, maybe you'll come across what are the uses of concave mirror. Concave mirror is used as a shaving mirror, jewelry mirror, dentist mirror. And what are the uses of convex mirror? It is used for rear view in vehicles. It is used in street lamps. You understand? It is used in shops also for wider view. Okay, right. So, yeah, 6 cases of image formation. No, I just adjust my screen to show you all the 6 ray diagrams in the same screen. Yeah, what you said will definitely we have to come to those. All right, so image formations. No, just see, I recapitulate. What was the first case of image formation? First case of image formation in case of concave mirror, object at infinity, image forms at or on F. Okay, so object at infinity means what? We will not, or we see that the object, up arrow will represent object. Up arrow will represent object. And if I don't touch this ray to the principal axis, its meaning is it is at infinity. Okay, so this is the object. Now, so this is the parallel beam of light rays from this object at infinity. If object is at infinity, image forms at or on F. So the parallel beam of light rays from object which is at infinity. So first rule of image formation, if a ray of light is parallel to principal axis, after reflection, it passes through F. After reflection, it passes through F. After reflection, it passes through F. Okay. Now you see this image is formed at or on F. In a way on F. So here this is the image. And this is the object. Okay, object at infinity, image forms at. What is the nature of image? You see, this image is formed by actual intersection of reflected light rays. All the reflected light rays intersected on F. So this image is a real image, and all real images are inverted. All real images are inverted. Okay, and because all the rays intersected at a point doesn't have much dimension. So this image is a much diminished in size. Okay, so that's the first one. So object at infinity, image forms at or on F. These parallel rays are parallel to principal axis, so image formed on. If this beam is not parallel to principal axis, image will form at F, not on F. Then also image will be diminished. Okay, the second case of image formation, fadafat I draw before we wind up. The second case of image formation, this is the pole, this is F, and this is C. And where is the object? Object is beyond C. Object is beyond C. And where image forms? Image forms between C and F. Image forms between C and F. So for any ray diagram, I want a minimum 2 rules. That rules of image formation we have drawn. So I'm talking about those minimum 2 rules. Okay. So here you see from the object, a ray of light incident parallel on the principal axis. How it should go according to the first rule, if a ray of light is parallel to principal axis, after reflection, it passes through F. After reflection, it passes through F. First rule is over. Next rule, if a ray of light is incident through F, through focal length, after reflection, it should go parallel to principal axis. Second rule. Now what happens? The point where the reflected light rays have intersected, that point is the location of an image. So this point from here, you have to drop a perpendicular on the principal axis. And this becomes image of the object. So image formed between C and F. Okay. This image is formed by actual intersection of reflected light rays. So this image is a real image. Real image is an image that is formed by actual intersection of reflected light rays. Real image. So it is upside down, upside down. You see, object is erect, but image is inverted. Okay. And this is inverted, and this is small in size. Why it is not a diminished? Why? Because the light rays did not intersect at a point.